here's Pascal's triangle. So I'm going to show you how to make it. Pascal's triangle starts with a 1 at the top. And every single time down the side, we make a 1. So you could do this a couple times if you'd like. But here's how we get the inside. So what is 1 plus 1? Well, that equals 2. What is 1 plus 2? 3. 2 plus 1, 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Again, 1's down the side. 1 plus 4. 4 plus 10. Or sorry, 4 plus 6. 6 plus 4. 4 plus 1. And then the 1 down the side. Okay? This is Pascal's triangle. So let's take a look at some of the patterns. So first of all, there's 1s all the way down the side here. This side and this side. Okay? Now, that's the first diagonal. The second diagonal increases by 1 each time. So that's supposed to be 1. So it goes from 1, 2, 3, 4, 5. Okay? So it increases by 1 each time. The third diagonal, sorry, I'm going to circle the second diagonal. So this is the first diagonal, this is the second. The third diagonal, they actually add to perfect squares. So for example, 1 plus 3 equals 4. Well, we can root 4. 3 plus 6 equals 9. We can root 9. 6 plus 10 equals 16. We can root 16. So those ones are perfect squares. And I'm going to take all this off. If we take a look down the middle, Pascal's triangle is actually symmetric. So let's go right down the middle. Okay, on this side there's a 1, on this side there's a 1. On this side there's a 3 and a 1, 3, 1. Okay, 4, 1, 4, 1. 10, 5, 1, 10, 5, 1. So these numbers are symmetric down the middle. And here's one that you probably wouldn't solve, but I'm going to give it to you. The horizontal sum. So when we talk about the horizontal sum, let's delete this again, just so it's a little bit neater. Okay, when we talk about the horizontal sum, we mean if we take any row. So for example, this is row 0, this is row 1, row 2, row 3, row 4, and this is row 5, okay? Remember that the rows always actually start at 0, it doesn't start at 1, but we can know this because row 5 has a 5 in it. Row 4 has the 4 in it, and so on, okay? So again, horizontal sum is taking any row and adding all these numbers up. So this one's easy because 10 and 10 is 20, plus another 5 and 5 is 10, which is 30, 32. I get 32. But if you wanted the short form of this, you can just simply put 2 to the exponent 5. And we get the answer 32. And we're going to take a look at that. Okay, so the first 6 terms in row 25 in Pascal's triangle are 1, 25, 300, and so on. They're written here. Determine the first 6 terms in row 26. So I would take 1, 25, 300, 2300, 12,650, and 53,130. Okay, we know going down the side, we always put a 1. We add these to 26. We add these ones to 325. We add these ones to 2,600. We add these ones to 14,950. And we add these ones to 650 plus 53, 130, 65,780. That's 1, 2, 3, 4, 5, 6. Those are the first 6 terms in row 26. So if we take a look at this, we can write Pascal's triangle using term numbers. So the 1 here is row 0, term 0. Okay? And then this would be row 1, term 0, row 1, term 1. Okay? Row 1, term 0, or sorry, row 2, term 0, row 2, term 1, row 2, term 2. Okay? And we see that these are added. So if we actually take a look, so example 2 asks us, use Pascal's triangle to write a formula for each of the following terms. Well, if we have term 12, 5, what this actually means is row 12, and it means term 5. Where did this come from? So I always think, where did it come from? Well, we know that it came from row 11. That's an easy one. Okay, and let's take a look at example 1 just to kind of figure out where this came from. So this is term 0, 1, 2, 3, 4, and term 5, 0, 1, 2, 3, 4, 5. So, for example, term 2 came from 1 and 2. So the previous one and the same one. Term 4 came from 3 and 4. The previous one and the same one. So going back to that logic, term 5 came from the previous one, which is term 4, and the same one, which is term 5. So we can write a formula saying term 11, 4 plus term 11, 5 equals term 12, 5. Okay? So term 40, 32. So again, we know that this came, we're talking about row 40, we know it came from row 39. So it's going to be two numbers added together from row 39. And when we take a look at the 32, the one before it, and the same one. So a formula for the term 40, 32 is term 39, 31 plus term 39, 32. And the final one. This is a general one. So we have term n plus 1, r plus 1. Okay, so n plus 1, we'll subtract 1 from that, we're left with n. Now r plus 1, this is still going to be r plus 1 because this one's always the same. So this one must be r.